So welcome to my presentation today. I'm going to start a new chapter, Synoptic Meteorology. But before I start this chapter, uh, I should also discuss a little bit about from the last classes, because in the last class we have discussed one issue which is, I think, little bit differently explained because of misinformation. One is, can you just can you see my can you see the PDF file now? Is it okay to you? Can you see that PDF file here?
No, sir. We can see the slide, sir. So now we can see, sir.
You can see. Is it okay now? PDF file.
Yes, sir.
Okay. So in
Yes,
the
sir.
last class, sorry. In the last class, I have discussed that the snowflakes, formation of the snowflakes and pattern of the snowflakes. I discussed about the dendrite formation, and someone asked me that why it is more common about the dendrite formation and about the temperature, about 12 degree and 16 degree. But actually that was a mistake. That was not 12 degree, that is minus 12 degree and minus 16 degree. So I have discussed that the ground temperature should be 12 degree to 16 degree, but actually it should be the not the ground temperature. It could be it is the temperature of the snowflakes where it has been formed, and it is inside the clouds, that is minus 12 degree to minus 16 degree centigrade. Now the question is, there is two questions. One is why dendrite is the most common form design, and another question also very interesting that I should discuss with the same thing, because that is also very interesting about the, is it possible to have a snow if the ground temperature is more than the freezing condition. That means plus temperature, is it possible? Is it possible to have a snowing in 10 degrees centigrade when the ground temperature is 10 degrees centigrade? Is it possible snowing or not? So these two questions is very much interesting. I am going to describe it very quickly. So first of all, dendrite. Why dendrite is the most common? Why the plate formation or the column formation or needle formation or any other types is not very common? Dendrite is common um, because when a crystal formation has been happened, there are some conditions, and that is dependence on the differences between a maximum temperature, that is a differences between the water and ice saturation vapor pressure. So vapor pressure, which is saturation vapor pressure, means in which pressure the vapor should be saturated. The difference between that two, inside the water and inside the ice, that is one condition of the formation of the snow. And this is why in that temperature the dendrite loves to form. Why? Because dendrite is a formation where, first of all, a single formation has been happened, and then with its surroundings, that when temperature has been varied a little bit because it wanted to come to the higher level to downward, inside the even inside the cloud also the temperature varies. So in that cases, the surroundings of that smaller ice crystals that has grown a very smaller thin film of water, and that water is very much in a they have a behavior to attract some others. That means they also attract other crystal formations, and also attract other freezing liquid substances. And then, for example, if it is in the middle, so in the by the side there is another stick, for example a column shape has been come in here, and then another one come to here there. So with that cases, in different direction of the same one, when when joins one after another, they are looking like a pattern of the fern structure, like a branches of fern, branches of many trees. So that's why dendrite is the most common. And now the temperature minus 12 to 16 degree, it is the most favorable condition of an ice formation, snow formation inside the cloud, which is much more dependent on a particular locations. This is one. Another thing is when it has been grown, so dendrite crystals are more like to grow with that differences between the ice and the water, that means the temperature differences between the ice and water, that is also a favorable condition of the differences of the saturation vapor pressure. So two things, one is temperature, another is vapor pressure. And that's why that in this temperature, the dendrite is like to be formed. So that's why dendrite grows rapidly rather than the other types of design. This is one thing. Another thing is, see here, uh, is it possible to grow the snow when the temperature is more than 0 degree or not? Yes, obviously it is possible, but there should be some condition. So to form a snow, it should be dependent on two basic things. One is, as I discussed now, one is temperature, another is humidity. So when temperature is in higher condition, that means when your ground temperature is more than zero, maybe 2 degree, 3 degree, or even 5, 10 degree, that means when the snow are coming, they are being heated up. And this heated up means the ice turns to water and vapor. That means your snow is no more in there. Okay. But if your relative humidity is very low, your relative humidity is very low in a certain condition, that means your the when when the snowflakes melted, that is very swiftly they turn to water. That means they create some moist position of the environment, and that reduces your air temperature. Okay, so the condition is when your air temperature, when your lower temperature is more than 0 degree, it is possible to form a snow, but it will dependent on the relative humidity. It will also be dependent on the wet bulb temperature. What do you mean by wet bulb temperature? Wet bulb temperature is, I also discussed in earlier classes, that this is the temperature of the air, that means inside the air, when the evaporating water, they have, this is the lowest temperature, that means this temperature can attained by the evaporating water inside the air. If the temperature is much lower than that, that means they cannot hold it. That means they will gonna lose their behavior. So this is the lowest temperature inside the, this is gonna lowest temperature that can be attained by the evaporating water. Evaporating water means that is vapor, that is not in a gaseous condition. They can attain this lowest temperature. So when your snowflakes started to grow, that has been grown up, and then when they wanted to come to the down, if your condition is like you have very high amount of the heat in downward, up to maybe, for example, it is 8 degrees centigrade, plus 8 degrees centigrade, but your snow should be melt down, but it will not gonna melt down if your wet bulb temperature is 0 degrees centigrade and your relative humidity is very low. That means your relative humidity may be 10 to 15 degrees, 15%, and your dew point would be minus 23 degrees centigrade now. So uh, dew point is in your favor, and then your relative humidity is very low, and your wet bulb temperature is 0 degree. Then it is possible to form your snow even it is in plus temperature. So maybe your question is now, in some cases of Bangladesh and many other countries, we do have such temperature in our winter time. Why there is no snow falling in these areas? Why the snow is mostly falling in the cold countries? The answer is, when your snow is falling from the top to the downward, that time you need a time, and within this time, if all the environment is all of the conditions is such like that you are getting the heat from all over the conditions, then your snow will gonna melt. Even with the high amount of the strong wind, it has not been possible, because that is not enough, that can create such a favorable condition of the temperature. But in case of cold countries, when they are coming through the atmosphere, that the distance is very lower, because it can also form within a very short distance, because their ground temperature is very much low. Okay, and then even they can only go 1 kilometer to 2 kilometer, they can get minus temperature in the altitudes. But in case of our cases, we don't have such like conditions, because our upper environment is also very hot because of the tropical and subtropical locations. So that's why when the snow, even the snow is forming inside the high level clouds all the way along, maybe it has to come from 8 to 10 kilometers higher altitudes, then it is also very impossible to have this in here, because that will gonna melt down. But it is also been possible that hail formation and other formation is possible, because hail can be formed in cumulonimbus cloud, and they are very much lower in a positions rather than the high level cirrus clouds. So this is why the difference are coming. So the answer is, we have possibilities of snowflakes formation in plus temperature if our humidity is very low, if our well bulb temperature is nearly 0 degrees centigrade, and then there should be a dew point. Maybe it is in here, if it is 8 degrees centigrade air temperature, then dew point should be minus 23 degrees centigrade, then it might be possible. Even sometimes it is possible more that in more than 10 degrees centigrade the snow can form. But in that cases, there need to be a very good downdraft. That means vigorously the wind should come from top to down. It can only possible if you have a thunderstorm. So I think it is a little bit clear now from the previous class. Is it okay now?
Yes, sir.
Okay. So I am going to start the new chapter, synoptic meteorology today. Uh, Sorry. Can you see the slide now?
Yes, sir.
Okay. So synaptic meteorology is our new chapter. It means it is a branches or a subtopic of the meteorology which discuss the uh, environment, weather environment, or we can say it will discuss about the nature and behavior of the air of the atmosphere as a whole. On the other hand, there is another definition which is much more related to synoptic, that is dynamic. Dynamic meteorology is another sub branch which discuss about the equations that follows inside the air. That means in that cases they're gonna discuss about a single cell rather than a very large component of the air mass. So large component is discussed in synoptic meteorology. On the other hand, if it is a single molecule or a single cell, and which is discussed about the equations and laws of physics and chemistry, in the meteorological options of the air, that is mean dynamic meteorology. On the other hand, when you discuss about the pattern and the behavior, nature of a big chunk of the air masses, that is our synoptic meteorology. So in this chapter, we're going to discuss about the air masses, that means chunk of air, their origin, their behavior, and their patterns. And before that, we will also going to discuss about the wind pattern or wind circulation pattern of the whole world. And we're going to also discuss about the forces that is needed for to flow or to drive the wind. And then later of this chapter, we're going to also discuss about fronts. Fronts means accumulation or the behavior that will get from two different air mass system when come together. Sorry. So in practical sense, air masses cannot move alone. Maybe another air masses come from opposite directions or maybe in the same directions, but in different motions. So they're gonna mix. And when they're gonna mix, what would be the nature of that new air masses? We termed it as a front, and we're gonna discuss a little bit about that. And at the end of this chapter, the most interesting thing we're going to discuss about the some devastating or disruption of these air masses, because air masses always acting with some energy, and this energy is mostly associated with the heat energy which is coming from the sun, and that's why this energy should be well maintained inside the environment. And that main to do the well maintained inside the environment, these air masses oftenly create different devastating circulation pattern, which is named as cyclones, hurricanes, and also anticyclones, many things, tornadoes. And sometimes this is also accompanied with some thunderstorms and other things. So very interesting and very important topics about the disruption of the wind and air masses. We're gonna discuss at the later of this chapter. So I think from all of your chapter, this is one of the very interesting and important chapter for your for this syllabus, and we're gonna start now. And I need maybe a couple of classes to complete this chapter. So first of all, synoptic meteorology. What do you mean by synoptic meteorology? Synoptic meteorology normally discuss about the large scale weather system. Weather system includes the air masses because this is mostly associated with the air molecules and air pattern. And we don't discuss as a single element of the air molecules, and we don't discuss about a very smaller area of these things. Normally we do discuss about more than sometimes we do discuss about more than couple of hundred and thousand kilometers altogether, because on air mass is when it produces from some area, the chunk of the air mass may be extended more than 100,000 kilometers sometimes. So we need to see as a whole, because this creates a huge impact on our environment. So synoptic meteorology deals about those large scale weather phenomena. On the other hand, as I discussed before, dynamic meteorology is the study that discuss about hydrodynamics equation, fundamental equations of the hydrodynamics, and other system which consider the air as a single element. That means we only look a very smaller consequences of the equation, maybe the equation of physics, maybe the equation of mathematics and chemistry all together, how it reacts on a single molecules or single atoms inside the air. So difference between that two is depends on the scale. That means larger scale and a smaller scale. Now we're going to discuss about the force. We're going to discuss about the forces that is need to be need to be drive the wind, because when you say wind and when you say air mass, that has differences. Air masses are the chunk of the air molecules are the gases. On the other hand, wind means when these air molecules moves. That means the gaseous particles moves from one place to another. So that is meant to be the winds. So why moves from one place to another? The basic answer is due to the variation of the pressure gradients, due to the variation or differences between the air pressure. Why air is different? Why air pressure is different in different areas? Air pressure is different because the molecules of the air is different in different areas. If you go to the top of the top of the mountain, sorry, top of the mountain, then maybe your air pressure will be reduces, because you are moving a little bit upward, maybe 2 kilometer upward, and with these 2 kilometer, all the air molecules has been subtracted from your column of air. Sorry again. But if you go to the top of the sea level, then your pressure may be very constant, and this might be the normal highest air pressure. And that should be normally 1013 millibar, which we discussed before. Now, when you get in one city or in one area, you get higher air pressure. Another area you get lower. Another area you get lower air pressure. So that means you have few molecules in the second one and high amount of the air molecules in the first one. And normally the equation says that, or the nature says that, the higher level of air pressure moves to the lower air pressure area. And that is the main causes the winds that moves. But why somewhere it is higher and somewhere it is lower? Because of many regions. One region is temperature variation, because due to temperature the air molecules are heated up, and when the air molecules heated up, that means they are lighter and they wanted to go upward. And due to the upward movement, when horizontal air moves, that air also move further different directions. So temperature variation is the main causes of these pressure gradient or pressure differences. Secondly, earth rotation. Normally we do know when earth moves, all the other particles associated with the earth ground, that also moves. And also these air molecules also moves, because there is the attraction force between these air molecules and the earth. And with these movements, they also moves. So with these movements, winds also moves. This is another thing. Third one is frictional drag and turbulence. What do you mean by frictional drag? When wind moves, uh, the, the, the areas are not same always. Somewhere maybe it is very smooth, somewhere it might be a little bit up and downs. So when it moves, that means it causes some friction, and friction means you loses your motion, you loses your speed. And these, when you loses your speed, they're gonna move different directions. That's why the frictional drag, or when the turbulence happen, then air moves in different direction. Fourth causes is mountain obstacles. Think about when the wind moves, if there is a high mountain, then two things can be happened. One is, if the mountain is not big enough, then wind can crawl and then surpass the above the top of the mountain and go to the another side. But if the mountain is high enough, and also the area is, when it is high enough, that means they have very cold temperature in the top. So air molecules, they cannot raise very high because of the low amount of the temperature. So where the wind will go, because the amount of the air pressure, they can remain in such a place, and by the side of that there are some low pressure area, so wind will gonna move in that direction. So wind can move horizontally right, left, and maybe it can come back again, but the wind cannot surpass the mountain. So mountain obstacles also causes the drive of the wind. Then another cause is variation of the earth surface. As we know, the most of the areas of this earth is water. So watery areas, we said this is a smoother one. So wind gonna move very smoother way. Okay, and then when they come to inside the land areas, then there are different types of land uses. Somewhere it is very uncovered, somewhere there might be forest, somewhere there might be some cities, buildings, and many things. So depending on different earth surfaces, the uh, air also changes their behavior, and that directs the wind. For example, the air molecules has been heated up differently. Air molecules can go different direction because of the obstacles. Air molecules can change also their other type of nature, such as water vapor contents and many others. So the land use itself also a cause of wind movement. Another cause is the amount of the water vapor inside the air, because when you have much more humidity inside your air, that means you get much of the water in there. It creates it makes more heavier of your air molecules, and it would be tough to move from one place to another. So state of water is also very important. So if it is dry, it would be very light, it can move very easily. If it's not dry, then it cannot move very quickly. It should be very tough to move from one place to another. So these are the basic causes of the air movement, the wind movement. Wind movement and air movement is also same, but wind can move by these type of forces. Now we come to discuss about the circulation pattern of this wind, or we can say this is a pattern how we can see as a whole of the world. So wind, basically, if you see in our practical sense of a local airflow, you can see sometimes it is coming from right, sometimes left, sometimes front, sometimes back. But this is a day-to-day condition or time-to-time variation. If you do the average of these variations and it will cause the average of more than 20 years, then you will get a pattern, and that pattern is termed as general circulation pattern. And now I am going to discuss um, about this one. So see this circle. Don't confuse about the outside arrows. Concentrate only inside of the circle. So as you have already understand your as you in your geography class, you do understand about the some of the geographical differences. So this is your 0 degree latitude, we say equator. Can you see my cursor? Hello?
Yes,
Yes, sir.
sir.
Okay, so this is our equator. Okay, 0 degree latitudes. uh, in by the side of this area, the wind gradient is very low. The wind pressure is very low. Pressure gradient means the differences of the pressure, only 5 degrees centigrade. Okay, we say this is doldrums because because the gradient is not much more. When the earth moves, these are the area that is much more very stable than other areas. So that's why these are the 5 degree north and 5 degree south. We say this is doldrums. Okay, and the light and variable winds within this belt can be found. After that, you see from here to 30-degree north, this is the area where the air moves, wind moves from right to left. The pattern is right to left. And if you say again, if you see in the southern area, southern hemisphere, it is also right to left. And these always come to a clockwise direction, clockwise direction. And this is the way how it moves. And this area we termed as this after the doldrums to up to that, these 30 degree north and 30 degree south, the air moves in this direction. And in between these areas nearly 30-degree north, uh, beside the 30-degree north, we say this wind as a northeast trades and southeast trades, northeast trades and southeast trades. Why it is that? Because these winds are tried to use in ancient time for ship movement. Okay, the ship, that time there was no engines, so the sailors or the ships are mostly dependent on the wind circulation pattern. So in these areas the trade ships were very prominent. That's why this is named after them, that activities, northeast trades and southeast trades. Normally that has mostly been happen in northeast trades, because in the southeast areas of that area is not very common for trading system from long time ago. Anyway, so this is the area where the wind moves from right to left. And in between these two, if you see the land pattern, after the 0 degree, if you see this area, this is our tropical regions or maybe subtropical regions, and this is the area where we have maximum heat and maximum precipitation that happened in here. So precipitation, mostly the rainfall and the temperature, makes this area for a good environment for the forests. So that's why it is written as forest. On the other hand, if you go a little bit upward, then you can also find some desert area in there, hot desert area, even in the north and southern hemisphere. So in the southern hemisphere, there are some areas of the Africa. In the northern hemisphere, there are some areas of the Middle East. So these are the areas we can get desert areas. And then after the northeast trades and southeast trades, the next line from 30 degree to 60 degree, these are the areas we say westerlies. The wind name is westerlies. So prevailing westerlies from 30 degree to 60 degree. And in these cases, the wind again change their directions. Always keep in mind, this is an average condition. This is not a local condition. So if you ask me, can I see the wind direction in any time? I should say no, because this is an average direction of the 20 years average. So mostly you will see that, but not every time. So westerlies wind again go in opposite direction, and this is again in left to right, left to right. So in southern hemisphere also and northern hemisphere also. But there is an interesting word in here, which is just after 30 degree north. It's written as, this is the latitude of the 30 degree north is named after horse latitude. Horse latitude, 30 degree south and north. Horse latitude. This is very interesting. Why it is horse latitude? Rather than that, the other names are quite okay. And after that, I'm going to explain that. And then after 60 degree north, then further downward, further upward, that is the area up to 90 degree. This is the area where the wind movement is not so violent, and then the area is also having very not having very high pressure system. That means the wind molecules are very stable in there, and similarly in the southern hemisphere, and so that we can get some cold areas in there. So we say cold desert area. That means they're desert, but the ice desert. This is not the sandy desert. This is ice desert. Now come to the horse latitude myth, or we can say sometimes you can say this is also history, but in ancient times, what happened between the Pacific and between the America, Latin America and North America, from that part to the Europe, there was always there they started their business, and during that business, as there was no engines invented in that time, so they were much dependent on the wind circulation pattern, and they needs couple of months to come from one continent to another continent, and from one continent they took the horses to the other continent and they sell that, and again they buy some products from there and come back to the continent. This is their normal business process. You can say this is a myth, or you can say this is a history, because we have learned like this. So anyway, think about 2 months journey. It's not always 2 months, but I'm just giving some example. So in 2 months, maybe in the very last, before 15 days, the wind has dropped, which should be go from left to right. In that time, the wind has been dropped. That means no more air movement. It is very calm and quiet. Okay. So, so before they need 15 days to reach the land surface, now without the wind movement, they might need another 1 month more. And in the same time, their food and water should also be finished, because they had a target before, and maybe they have some extra, but not too much. And with their full of horses in their ships, they are now struggling with the food. So they don't have enough food for another 2 months or 1.5 months, but they need to reach the land surface, and they cannot come back again because they have already 1.5 months on their way. So now they don't have enough food for all of them, and then they have to depend on the wind, and they have to reach within 15 days or within 1 month. But with this situation, they might need 1.5 months or more than that. So my question is now, what should they do? Can you hear me? Hello?
Yes, sir.
Yes. So what should they do? Yes, sir. Okay. So what should they do? Do you have any idea, anyone? Do you have any idea? They don't have enough food for all of them. For they may have some 1 month food, but they need maybe another 1.5 months with this situation, or more than that. Maybe they need another 2 months with this situation if there is no wind, and they have to reach. So what should they do? Anyone have any idea? If you were in that situation, what should you do?
Sir, maybe migration.
From where to where? Migration from where to where? They are in the middle of the sea. So where should they migrate? You are in the middle of the sea. inside the ship. So what should you do now?
So, so they can eat the horses, I think,
Yeah,
one by one.
very good idea. And they can survive, yes,
Yes, sir.
but they don't have enough water also. What should they do? Because they can't drink the salty water, no? If you drink the salty water, you're gonna die. So uh, what should they do? They don't have enough water also. Yes, they maybe it is possible that they can eat the horse, but what about the water? Anyone have any other idea? Okay,
Sir, they can collect the rainwater.
where they will get the rain? Where they will get the rain? There is no
Sir,
rain here.
in a show, Bear Grylls drank
Uh,
his own pee.
oh,
Okay, okay, fine. This is another solution maybe. Any other idea? Okay, so let me describe little bit because the latitude is named after horse latitude. So this is actually a sad story because they have to survive. They have to sacrifice their horses. So what they should do, this full of sheep of the horses, they throw these horses into the sea. They just throw the horses into the ocean. Okay, when they throw it, your vessels, that means your ship is very light in condition. Okay, is it okay?
Yes,
And
sir.
and they will also get the water which can be used for horses and which can be used for them. Altogether they have now enough water and food, and they throw all the horses because there are thousands of horses maybe in one ship. So they throw it to the ocean. They sacrifice it, but they can survive because their life can be saved from that, because with the lighter ship they can move little bit faster rather than the heavier ship. Is it make any sense? Does it make any sense?
Yes, sir.
Okay, so
Sir, we didn't
that's
think
why.
about like that, sir.
Sorry.
Sir, we didn't think about like that, sir. Throwing
Okay.
horses away.
Yeah, they should they did it actually. So so that's why it's, although this is very sad, but by this way they were survived. So that's why this latitude is named as horse latitude. Okay, so between in these latitudes they move from one direction to another direction mostly. So that's why this latitude is named after horse latitude. I say it again, this is a myth, and this is I have not enough well, if I get the references I will give you, but this is the way how our teachers has been described. So that's why it is named after horse latitudes. And after that and below that, the wind direction is also different. So mostly the wind pattern has been much more important between 0 degree to 30 degree north and south, because of these are the areas where the wind move very fast. And most of the cases, what are the different natural phenomena related to wind, we can found in these latitudes. Rather than that, in 60 degree north and after that, we have very hardly we do have any such calamities in there, because of the movement of the air is limited in there. Although there are some low air pressure system in that area also. But however, the mostly we can see these things in the tropical and subtropical regions. So as a whole, this is we called general circulation pattern. Think about that, or mind it that inside this word we don't include any wind. We say general circulation pattern. So in your exam, it will come general circulation pattern. You should keep in mind that you have to describe the wind circulation pattern, not others. For example, there are some other circulation pattern also, wave circulation pattern or other things also. But when we say general circulation, it means wind circulation, and this is an average condition all over the world. Okay, I think this should be enough for today, and if you have any question now, you can ask me regarding to this lecture.
Sir, in the first slide, there's the line that view together or view at a common point, sir. What does it mean?
Sorry.
Sir, in the first slide, sir,
Yes.
synoptic means that view at a common view together, sir. There's a line, sir. What does it mean?
Okay. It means you should see the weather pattern as a whole. You should not. There are many equations that can be used for a single molecule. For example, if you add more temperature and your volume is constant, then what will happen? You can explain in a closed box. Okay, and now maybe there are some other air come together in that boxes. That means there is no closed boxes actually, no. In reality, there is no closed boxes. It is all over, it is open. Okay, so when we wanted to describe a pattern, we do consider is in a very ideal condition, but when that is our dynamic meteorological description. But in case of synoptic meteorology, we don't see very in one equation how it reacts, how it works. In synoptic meteorology, we should have to see all impact at a time. So that's why it's said here that view together or view at a common point. So you have to think largely rather than a single equation or rather than a single behavior. Is it okay now?
Yes, sir. Thank you, sir.
Okay. Is there any other question? Is there any other question? No. Okay. So if you don't have any other question, then may I ask Siam that we can take another class in next Monday?
Yes, sir.
Okay, and I wanted to take a little bit longer class, means 2 period maybe 2 45 minutes. Is it possible?
Yes, sir.
Okay, so in the next class, from 11:30 to another 2 class, I'll take.
Okay, sir. No problem, sir.
Okay, so thank you all of you for joining me, and hopefully we'll come back to in the next class in next week. Thank you all.
Thank you, sir.